of physics involved, why this loop exists. I don't want to talk about the loop. It's interesting physics, not so relevant for this course. But if you increase, what I want to impress you is that if you increase the energy, this is done in one kinetic energy. If you increase the energy, what is the angular scattering intensity look like, distribution look like? It becomes more and more focused, if you like. So here, I'm increasing my energy going down this way. So energy is increasing as I come down on this direction. You can see here, on my highest electron scattering here, you got, what do you got? You got a very sharply focused compared to the low energy one, as you would expect, right? Because this is known as a searchlight effect, because if you go higher and higher in energy, you can really pinpoint where you're going to go is because of this angular distribution. And obviously the reflected beam is much less on here. The backscatter cross section is much less. Okay? So, and this side is just a way to plot, instead of polar plot, it's trying to generate a linear plot, that's all. And so really, this is easy. I think you can think of it as moving a detector around the object, and this is the amount of electron you pick up at different angles. Okay, and all of these really depends on, in physics, really depends on a transition matrix. I think we should skip this because it's over the head of most people. You need electron scattering theory to understand transition matrix, but what I want to show you is that you could calculate this. There's a way to calculate this intensity inside transition matrix. Okay, so let's not talk too deeply about this, but just to know quantitatively, you could calculate the scattering cross section of electron scattering. Okay, what I want to do next is to tell you what is the limit, what in terms of information content that you can get out from a lead pattern, right? We have an ideal surface. The lead pattern is precisely the reciprocal lattice pattern, right? So it's very powerful. If you see a lead pattern, you know the reciprocal space lattice, and hopefully you can infer what the view space lattice is from that using the the transformation matrix that we talked about earlier. From this reciprocal space lattice, we can deduce the real space lattice neck, right? So here, for example, I tell you some tricky thing, right? So here you have my lead pattern. Okay, so this is actually not a lead pattern. Let's think of it as not a lead pattern, right? What do you see? Right? You see all this open circle. Okay, so open circle is your substrate point, right? Open circle is your substrate point, your 1 by 1 spot. You can see this is a hexagonal pattern. Okay, and then the red circle one, the black point, will be your overlay point, right? And what is the black point correspond to? They correspond to 2 by 2 pattern, right? Because this is every 2 units, right? Every 2 unit with reference to the substrate, you have an absorbing point. Okay, so then you call this 2 by 2. All right. Now, what happened if I also same thing? Instead of my absorbate covering all the black point, right? My absorbate cover just the square point like this, right? So what I'm trying to tell you is that you could have complication between 2 by 2 and 2 by 1. And how do you get 2 by 1? Okay, if your point here. Okay, I think I reverse what I said. Okay, so let me try again. We have this is my lead pattern. Okay, So this is my real space pattern, this is my lead pattern. In my lead pattern, okay, let me go reverse. In my lead pattern, my substrate spot, my bright spot are the dark point. The dark point is my substrate. Let me write this down. Substrate point. Okay? My weakest spot is my open circle. This is my overlay. Okay, my overlay. Okay? So what do you see? This is my 1 by 1 spot, and half, you have a fractional spot, right? A fractional spot, which is half the length, right, of my residual space of my substrate vector. So this therefore corresponds to 2 by 2, because in real space, you actually have twice the distance in order to generate 1/2 0 spot, right? This would be my 1 0 spot like this, okay? Everybody follow that? So this is my, I'm talking about my residual space here. Now, what I'm trying to tell you is that, okay, once again, I would have, in this pattern here, the blue is my substrate spot, same as this one. Those are the intense one. And now, instead of seeing all the weak spot populated, I only see one set. I only see, for example, my triangle. Let me color it in like this. I see one set. I don't see this one. I don't see the square. Okay, so this the square I don't see. I only see one set of spot. And what is the so what is this lead pattern, right? Because here you can see because the triangle could also overlap the bright spot, which are this one, right? So I should draw my vector from here to here. That would be one unit cell of the substrate. From here to here is fractional half the unit cell of the substrate. So I should call this 2 by 1 because this is residual space, right? So this is half. I just randomly call this half 0. This is 1 0. Let's say, right? And this is 1 0 1. Let's say like this, right? Because I have no spot here, no green spot here. I have a green spot here, right? So my green spot could be populated here, 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 right? The green spot could populate on top of the bright spot. I just don't see it. So I count this vector as the same as my substrate. This vector is 1/2 of my substrate, right? So this is 1, like this. Okay, so that would be a 2 by 1 pattern. All right. Now what happened? Suppose I have another pattern, which is identified by my square thing, like this, my square, like that, and my triangle has disappeared. I just have the square. And what do I have in this case, right? In this case, I would have, okay, let's think about this. I would have this, right, is one spot. I don't have the triangle here, so this is clear. So the square could cover this spot, this spot, this spot, this spot, this spot, this spot, right? All the bright spots and the square spot. The square could cover that. So here my square could actually cover from here. Let me draw it this way. From here, right? And from here. And this pattern I call 1 by 2. Okay?